Hello everyone, we're Team GMAT 770. We are focusing on teaching and training GMAT test takers all over the world, especially in North America and in Asia. Our goal is to help GMAT test takers to pass GMAT tests before they apply for graduate schools all over the world. The test score of each of our team members is about 750, and the co-founders of our team got GMAT test score 770, so that's the reasons why we call this name. I'm the math teacher, Corinne, of our team, and I hope that from these lessons about math, you will easily pass quantitative parts in GMAT test. So are you ready? Let's get started. Hello everyone, welcome to our new lecture, Combination, Permutation, and Probability Part 1. This topic is actually difficult, so we will have 2 lectures to explain it. In Combination, Permutation, Probability Part 1, we will focus on the definition and basic rules of these 3 concepts. And in Part 2, we will move on to some more difficult questions you will face in this lecture. In today's lecture, first we will talk about the definition and computation of CMP, which is short for combination and permutation. And second, we will move on to the 2 basic rules, addition rule and multiplication rules, and the usage of these 2 rules for you to solve the questions. And third is a definition of probability. Okay, so first we'll talk about the definition and computation of CMP. First, permutation. We'll use a letter P to represent the permutation. So what is a permutation? Well, a permutation is an ordered sequence of elements selected from a given finite set without repetitions and not necessarily using all elements of the given set. So P and R, which is actually represents that you will have n elements in a given finite set, and R elements needed to be selected from the n elements. And you also need to put the R elements in order. So the computation of P and R is equal to the factorial of n divided by the factorial of n minus r. So here is how you compute the factorial of n. Well, the factorial of n is actually the multiplication of all the positive integers from 1 to n. So please remember that the most important thing for you to learn in permutation, and actually the difference from permutation and combination, is the permutation, you will put the elements in order, but the combination, you only need to choose the elements, but do not need to put them in order. So let's use some simple questions to explain how it works. So how many different codes can be formed using 3 different numbers from 1 to 5? So now you have 5 numbers in a given finite set, and you need to choose 3 different numbers from them. So P53 or P53 can represent the answer to these questions, which means that you will choose 3 different elements from 5 elements, and also you need to put them in order, since 1 to 3 and 3 to 1 are actually 2 different codes, right? So let's compute P53, which is equal to the factorial of 5 divided by the factorial of 5 minus 3, which is actually the factorial of 2, which is equals to 60. Okay, so let's move on to the 2 basic rules in this topic, addition rule and multiplication rule. So what is addition rule and how to use it? For example, if you have different methods to solve the questions, and each of the methods can independently solve the problems, so you need to add them together. For example, if you have 3 different methods, method 1, method 2, and method 3, each of them can solve the questions, so you will together have 3 methods to solve the question. And what is actually multiplication rule and how to use it is actually if you have different procedures to solve the questions. For example, there is 2 procedures for you to solve the questions, procedure 1 and procedure 2. And under procedure 1, you have 2 methods. And under procedure 2, you'll have 5 methods. And how many different methods for you to solve the questions is actually you need to multiply 2 by 5, which is equals to 10. So you will have 10 different methods to solve the questions. So please remember that what you add as method and what you multiply by is the procedures. Okay, so let's use 2 examples to explain how to use addition rule and multiplication rule. So how many different ways are there to arrive at destination B from A? So as we learned from the picture that if you wanted to arrive at B from A, you need to first arrive this point. So let's call it point C. That from A to B, that you will say that you have 2 procedures. Procedure 1, you need to arrive at C from A. In procedure 2, you need to arrive at B from C, right? So in the first procedure, you have 2 ways. And in the second procedures, you have 3 ways. So as we learned before, that if we have different procedures to solve these questions from A to B, that you need to multiply them together. So you need to multiply 2 by 3, which is equal to 6, which means that you will have 6 different ways from A to B. So in these questions, we use multiplication rule since you have 2 different procedures in these questions. So here is another example. Actually, the question is the same as the last one. How many different ways are there to arrive at destination B from A? But the picture is different. As we learned from this picture, you only have 1 procedure to arrive at B from A. And in this procedure, you have 2 red lines and 3 black lines. As we learned before, that each of the lines can independently solve this question, so you need to add them together since they are different methods. So you will add 2 to 3, which is equal to 5. So you will have 5 different methods to solve this question, 5 different ways to arrive at B from A. So in these questions, we use addition rule. Okay, so let's move on to probability. What is probability? Well, the probability that event E occurs, denoted by PE, is a number between 0 to 1 inclusive. And how to compute the probability of E is actually use the number of the outcomes in E divided by the total numbers of all possible outcomes. For example, in the last picture, as we learned that from A to B, we have a total 5 different ways, and 2 of them are red lines and 3 of them are black lines. So we total have 5 different lines, 5 different ways to arrive at B from A. If I ask you that what is the probability of the red lines, so you need to use the number of the red lines, which is 2, divided by the total numbers of all possible ways from A to B, which is 5. So you will have 0.4. So 0.4 is actually the probability of the red lines from A to B. So actually we can say that probability is just an extent of combination and permutation. Combination and permutation is asking for the outcomes, but the probability is just one more steps. You need to use the outcomes divided by the total outcomes. Well, another special question in probability is independent events. So what is independent events? If the occurrence of either event does not affect the probability that the other event occurs, these 2 events are independent events. And if event A and event B are independent events, the probability of A and B is equals to the probability of A multiplied by probability of B. For example, if I tell you that event A and B are independent, and the occurrence of A is 0.6, and the occurrence of B is 0.5. So what is the probability of A and B occurred together? So we'll use these equations. So P A and B will equals to 0.6 multiplied by 0.5, which is equal to 0.3. So 0.3 represents the probability of A and B. Please remember that these equations will only satisfied when the two events are independent. So if you wanted to use these equations, please remember to find out whether these two events are independent or not. Okay, so let's have a quick summary of today's lecture. In today's lecture, we have some basic understanding of combination, permutation, and probability, the definition and computation of them, and some basic rules you need to learn in this topic. In our next lecture, Combination, Permutation, and Probability Part 2, we will move on to some more difficult questions you will face in this topic. So hope to see you in the next lecture. Bye.